Hey there, it's Mr. Alco from the Math Tub once again, and today we're going to look at how to use our SOH TOA or our trig ratios on how to find an unknown side length. So I have two examples here, and they're a little bit different, so I want to show you two different methods. So we're going to be moving through this fairly quickly. So example number one, first thing we need to do is we notice that we have an angle this time, but we don't know our side length. So we still need to use one of these three ratios, but we need to figure out which one it is. So a good way to start is always start from your angle and figure out where your opposite side is. From there, you can kind of work your way backwards and say, okay, I know I have my hypotenuse, which means this is my adjacent. So if I don't have an opposite, I can't use sine, I can't use tan, but I can use cosine. And this is how we're going to fill it out. So we have the cosine, but this time we're going to plug in all our values. So we know the angle this time. Cosine of 31 equals opposite. Sorry, cosine is adjacent, which is our x, divided by our hypotenuse, which is 15. So what we do now is, just like any other algebra problem, we need to get our x value by itself. Currently, it's being divided by 15, which means to get rid of it, I'm going to multiply by 15. And because of that, it's going to cancel each other out. But because I multiplied by 15 on this side, I need to make sure that I multiply by 15 on the other side. So now I have an equation that says 15 times the cosine of 31 equals my x value. And then all I do is I'm going to take it, I'm going to plug it into my calculator, but make sure you have that multiplication symbol in there. Okay? And we're going to end up with x equals 12.86. And we can look back and say, okay, it's actually probably pretty close because our x value is less than our hypotenuse, which is exactly what it should be. Now we're going to move over to our second example, which is a little bit different. The process is going to be very similar, but there's going to be one major difference. I'm going to show you what it is here in a second. So what we're going to do once again is we're going to start with our angle and say, okay, which of the three trig ratios am I going to be able to use based on this question? So I have an angle. From my angle, I have my opposite side, I have my hypotenuse side, and I've identified my adjacent side. The parts I know are opposite and hypotenuse, which would make it the sine feature. So I'm going to write it out. Sine of, go to our angle, in this case 70, equals opposite, which is 22, divided by x. Now this one's a little bit different. So I'm going to show you a quick way of doing it because now our x is on the bottom. We can't just make the 22 disappear. We have to follow those algebra rules. So what I'm going to show you is a trick. One quick way of solving it is if you ever get into a situation, just switch your x and your sine 70. Now if you don't look and you go, well, I don't understand how you got there, I'm going to show you how. This is the longer version of it on how we got to that point. So, but this is the fast way. This is the long way. If we want to get rid of an x, we have to do the same thing we did here. So I'm going to multiply by an x value, which is going to cancel, which means I also need to multiply by an x value on the other side. So my new equation is x times sine of 70 equals 22. So now I need to get rid of, I still need to get my x by itself, so I need to get rid of this sine 70. So I'm going to divide by sine 70 because these two are being multiplied together. So I can use a division to cancel it out. But I'm also going to do sine 70 here as a result. So now that this is canceled, I'm still left with x equals 22 over sine 70. So rather than going through this big long process, we can just switch these two values and we can plug it into our calculator again. And once we do it on this time, we'll find out that x equals 23.4, or whatever bunch of numbers there are that you have to round to based on what your significant digits are. But once you get to this point, we can check it against what we know. We know that this should be higher because it's the hypotenuse. So we have 23, I have 22, so there's probably a good chance we're looking good unless we made a mistake somewhere in here. But these are the two ways that we can solve for the unknown sides. So hope that's helpful. I'll see you again later. This is Mr. Elko from the Math Tub. Take care.